capabilities. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this particular module, we'll talk about the various separate and distinct layers of security available with file storage service. So as you can see on this slide here, there are various distinct and separate layers of security which you could leverage in order to secure your file systems and mount targets. So starting with IAM service, and again, every service we have talked until now and every service in OCI, you could leverage the identity and access management service to control actions like who can create instances, client instances, who can create the FSS VCN, and even who can create list and associate file systems and mount targets. So all those activities, sort of the control plane activities, can be controlled by your identity service, right? So you create your users, you create your add the users to the group and write policies. So you do authentication and authorization, and if these users don't have the correct level of permissions, they cannot create file systems, mount targets, compute instances, and virtual cloud networks, right? So pretty straightforward. We talked about that previously. There is also concept of security list, which is associated with your virtual cloud network and network security groups now, because I must add NSGs are also available now. So you could use security lists as well as you could use network security groups. We'll talk about those in the next slide. There's also something which is called export options, which basically is applying access control per file system based on source IP CIDR blocks that bridges the security list layer and the NFS Unix security layer, right? And we'll talk more about what exactly we mean by that. It gives you that additional security layer which you could leverage. And then finally, you could of course leverage the NFS Unix security. So when you mount your file system, you read and write the files, you could use different options, right? And as the caveat goes here, when mounting file system, don't use mount options such as no lock, resize, rsize, or wsize. These options can cause issues with file locking and performance. And again, if you go on documentation, you can read all about these. But there are four different distinct layers: identity access management, security list and network security groups, export options, and NFS Unix security. In this particular module, we'll look into these two in greater detail. So we looked into this earlier. In the previous demo, we had another client running here in the same subnet. But what you saw was that for these clients to access the file system and the mount target, you had to open certain ports, right? So Ingress, you had to open this port, these TCP and UDP ports, and for Egress, you had to open these ports, but these becomes the source ports for Egress, right? And we talked about this briefly. We do this for the TCP connections to survive the reboots, right? And we talked about the fact that you're running mount target here, it's highly available, right? So if let's say the server on which the mount target is running has to fail over, and you have a client here which has a TCP connection in flight, now the response, if everything is fine, the response goes here. You really don't need this piece here, right? It's not needed. But suppose the response is coming from here, and then suddenly the failover happens because end of day it's highly available. Now the response has to go from here, right? So that's why you have to open specific source ports. Otherwise, this particular TCP connection cannot survive the reboot. The packets will get lost, right? And if you don't write these other rules, so that's the reason why we have those rules available there, right? And the way this works is, let me see if I can discard those comments. So the way this works is, we saw this in the previous demo. In this case, we have to open certain ports for ingress, certain ports for egress, as we just talked about. Ingress, I'm just right now only this client is accessing the file server. So this is the IP address here, right? And I have to open TCP ports, destination ports, these ports, and for egress I have to open these specific ports as source ports, right? Exactly the scenario we just talked about. If you want all subnets within VCN to access the file system, just change this CIDR to the CIDR for the VCN, then all the subnets can access the mount target, and we did that precisely in the previous demo. So we looked into that. We actually did the demo. I talked about the logic why we do that. Now let's look at export options. What these are? Security list is all or nothing approach, right? The client either can or cannot access the mount target, and therefore all the file systems associated with it. Pretty straightforward. You write those security list. If you don't have them, your clients cannot access the mount targets. In a multi-tenant environment, um, using NFS export option, you can limit client's ability to connect to the file system and view or write data. And we'll look into this into more detail as to how this works. When you create a file system and associated mount target, the NFS export option gets created. So you don't have to create this. So this is automatically created when you create your mount target. You create your file system and associate that to the mount target. But it is allowed, it is the entry there allows for that file systems are set to allow full access for all NFS clients. So it has full access, and you really you all the clients can just fully access all the file systems, right? And basically this is the rule which goes there. Source is all IP addresses, privileged source port is false, read write access is there, so you can read and write, and identity squash is none, right? So what does it look like? If I just quickly go to my console, I can show you. If I go to my console here, right, I have the file storage service here, right? So this is the file storage service, file system we created, and right here is the mount target. Right here is the mount target, and if I see, if I click on my file system, I can see that this is the export path which got created. And if I look here, you can see that the export options already got created, right? So it allows access for every IP address. If the access is read write, and other options are just set to no to none, and port is open for any port, right? So this is the default option you get when you create a file system and the associated mount target, right? So pretty straightforward. Now, what does the export option really do? So now let's look at a scenario. The previous scenario, we had something like this, and of course we were running both instances in the same subnet in right now, in our demo, but right now it's those instances are running in different subnets. Now let's say we create a mount target and we create a file system A and we create a file system B. Pretty straightforward, because we talked about a single mount target can have up to 100 file systems, right? So of course when you create a mount target, you're going to have multiple file systems running on it. But client X here has read write access requirement to file system A, but no access to file system B. It shouldn't be able to access file system B. On the other hand, client Y has read access to file system B, but no access to file system A, right? So if this export option was not available, you could either open this client access here, or you could open this client access here, right? And they could access every file system, right? There is no granular set of access permissions you could specify with your security list, right? But now in this case, because we have this export option feature available, I could do something like this, where I specify that for my client X, I have the read write access, right? And to whom I have the read write access to my file system A, and for client B or client Y, I have access to file system B, but I only have read-only access to file system B, right? And so I'm meeting this requirement, and I'm meeting this requirement using this using the capability around export option. So how does this really work in action? So let me go to my console and show you this really quickly. So as you can recall from the previous demo, we had two instances running here, two clients, FSS1 and FSS2. They are running, both are running in the same subnet, so that's not a problem. And right now I can both of them can read and write to this file, right? So we saw this earlier. I can come to this from FSS1 here again, and it allows me access, right? So I can actually access my file and I can write it, right? Pretty straightforward, nothing different than what we just did in the demo. Now if I come here, I could change this, edit this NFS options. I'm able to do this because every client has full access to all the file systems running here. So if I click on edit here, first thing I could do is I could give only read-only access, right? So for all the source port, or I could just do for the specific CIDR which I just had. So if I just update it here, right, and go back to my file system one, my client one, and try to write something here, you would see that I don't have write permissions again anymore, right? It's saying cannot write to this file because I just changed my access level here, right? So I just said read only, and so I cannot go ahead and access the file system in a read write mode anymore. Now we could do certain some more things here, right? So for that particular instance, the IP address is 10.0.2.2, and I could say read only access to that particular instance. And the other instance which we are running, the second client instance, the private IP is 10.0.2.3, and right here I could say give a read write access, right? And I can update my permissions like this. So now if I go back to my first client FSS1, which is 10.0.2.2, I have only read only access, right? So if I bring this file again and I want to change things here, right, change and save the file, I cannot, right? Because it gives me it's giving me I have read only access, so I cannot change the file. But if I go to my second instance, which is which has read write access, which has both read and write access, just bingo, I can go ahead and change it, right? So what we just did is for the first client, we change our permission to read only. And for the second client, we change our permission to read and write. And so we could access it even though they belong to the same subnet. Right now, I have only one file system running. But if I had many file systems running, I could control granular access using capability like this. And if you come to this on our documentation page, you can read a lot more about export options. This is a more complex topic, so we covered this in greater detail in our level 200 modules to 200 videos. But you can see different scenarios here, right? The first scenario, if I scroll down, is the host access based control host based access, and this is exactly what we just showed in the slide here, right? So it talks about client A, client B, how you can control the access, and it gives you some console example, CLI example, etc. The one we just did is limiting the ability to write data for specific IP addresses. So if my client is running this IP, private IP, which we just did, to read only, we did that read only for one client, and for the other client we did read and write both were running in the same subnet. And the third one is we can have more secure access to limit the root's user privilege and things like that, right? So in our 200 module we talk more about what a privilege port is and what identity squash are, etc., right? For this one we can skip all the details, but this is the page where you can find all the information. All right, so with this module, again, we talked a little bit about security list. We didn't really cover network security groups, but the behavior is very similar to how we did open certain ports for TCP and UDP, both ingress and egress. And then we saw that, look, that is more high level, either you open access or you close access for instances, and then every instance has access to every file system. So if you want to go a little bit more granular, you use this option, this capability called export option, which gets automatically created when you create a file system and associate with a mount target. But you can go granular, and you can have things like one of your clients can have read-only access, other client can have read-write access, and so on and so forth. And you can make it really more detailed and have sort of more granular security controls. I hope that was useful. Thank you for joining this module. In the next module, we'll talk about snapshots. Thank you.